Okay, let's get started. And as I was basically saying before I started recording here, where is everybody today? We're all on daylight savings, so it's 3 o'clock California time right now. Time for class. Time to settle down. I still hear some people talking. Okay. I'm my TA, of all people, setting a good example, I see. All right. Okay, so as promised, today is, well, I got a lot of stuff to talk about today. Today is the midterm, the CSLO essay review. I'll tell you a lot about that. And I'm going to go over assignments number 1, assignment number 2, and a little lecture on collections, which is what we're going to cover today. Talk about some of the class-related stuff in regards to turning stuff in and stuff like that. So, today I am announcing the midterm. It's a take-home midterm exam, and it is open book, open note, open neighbor. However, you need to do everything yourself. You need to write your own answers to the exam. I don't want like 5 of you to all turn in the same exam. And this is posted out on the bhacker.com website. I will tell you, if you have problems with the bhacker.com website, lately the server, the database server, had a minor meltdown. It's overheating, essentially. So it's in the process of being upgraded right now. But as I'm teaching a class, I can't really be upgrading it. So it's taking it's a slow process. I might actually finish it tonight. Long story short, it's intermittently working. So if you have issues with it, don't worry about it. They'll probably be over with in about a day, hopefully. If not, I'll make extra arrangements to get it off of this server and put it on something else for you. But in the IT database, this is for the object-oriented design with Java class. I went in and, good, you can see this. Actually, let me see if I can make it a little bigger so you can actually, see. Oh, there it goes. It is getting bigger now. You'll see in here new ones. I put them towards the top right underneath the syllabus. This will also be put into the ITU EMS, but I'm just giving it to the TAs today, so that's not in there yet. They'll have to access it and put it in sometime this week. But you can get it from here, and what you'll see is 2 spots, a lot of verbiage on the midterm, basically explaining that it is a take-home exam, and then also reiterating the point that the final exam is in class, in person, absolutely no exceptions. Because you have a take-home midterm, I can't make any exceptions for the final, which means I got to see every one of your live breathing bodies in class, hopefully breathing, in class with a pen and a piece of paper to actually write your exam. So if you're in another state, you have to fly in, essentially, to go get and take it. However, as we get closer to the end of the term, I will be announcing the schedule for the final exam. And because I am teaching 4 different classes, chances are there's one time slot for some class on a weekend or on a weekday that's going to meet your schedule. So you don't have to take it at the exact same time that everybody else in this particular class takes it, but you do have to show up at one particular point to take it. So we'll have more information on that as we get closer to the end of the term, but I kind of wanted to make sure I reiterated that point so that you're prepared. And there's no surprises, and nobody's going to send me an email message asking for an exception, because I can't grant it. You just get an incomplete in the class if that's the case. But the midterm, and I'm going to go over the midterm in a few minutes. That one is a take-home. Also, the CSLO essay was posted up this weekend. And just in case you're having problems accessing the bhacker.com website while I'm in the process of fixing it, I would like to bring your attention to this. Oh, here we go. So I'm trying to make it bigger. This particular website, it is bhacker.com/exams. There's actually nothing wrong with my website. The problem is the database. And that forum system uses the database. And so that's what the problem is. The website itself works just fine. So if you have links to something, the links are going to work just fine. It's just going through the main interface that's going to cause you the biggest issue. But here we have, if you go to bhacker.com/exams, and this is a Google Chrome. I don't know why it's like grayed out like that, so it's harder to see. But it is exams. And if you go into there, let's take a look here, what you get. It looks like my old website, actually. What I did is I put links in here so you can get, oops, down here it's going to say it's going to download it, but you can get essentially all of the exams, the midterms exams, and all of the CSLOs, all of the new material that I put up this weekend. Might be handy just in case you want to start on it, but you're having problems accessing my website, can't get to it, and it's not in the EMS yet. But pretty soon, probably by the end of the week, all of this stuff will be in the EMS, so you can just access it from there. But I don't know, I like backup plans. So if you're in my software engineering class, I do risk assessment all the time, and so now the risk of you getting it is pretty minimal because it's at 3 different locations for you right now. So one of these is going to work for you. Hopefully this one will work. And if you're in the Oracle class, well, you'll find out after this class. I made the mistake of actually announcing a midterm when we don't actually have a midterm in that class. So I didn't even look at the syllabus. I just kind of assumed that we had midterms on everything. But the Oracle class that comes next after, we don't have a midterm in that class, no. We have 4 projects and assignments. And I forgot, because of those extra projects, that takes care of the midterm assessments. So anyway, that's why it says no midterm for Oracle. There's no midterm. So, well, yeah, I was like the last person to look at it, I think. Nobody, you know what though? No students or anything brought it to my attention, however. So I will assume that somebody noticed others outside of me, but maybe not. So, all right. So this is how you can get it. And if you still have problems getting it, you can send me an email message and I can lead you into the right direction. Let's go take a look at what it is. Now that I made everything so big, let's make it a little smaller so it fits on the page. Oh, no, I'm trying to figure out how to make it smaller. Hold on one second. There we go. Too many control this, control that. Now what we're looking at is the Object-Oriented Design in Java midterm exam. Here we go. It is worth 25 points total. You have 1, 2, 3 sections to it with some sample source code on the bottom. And each section has a couple of questions to it. I want to start at the beginning. I want to kind of give you some examples about how to approach the questions and what's required, what's expected, to sort of minimize, hopefully, the number of email questions I'm going to get. Okay, so the first section, which is worth 15 points, total of 25, when you add both sections together, you answer the following question using words. Words. No source code. No source code on example number 1. And a sentence or 2 is sufficient. I don't want you to write a novel. As an example, list the 4 main characteristics of object orientation, and I put a pie there. I practically gave you the answer. So when you talk about abstraction, polymorphism, inheritance, encapsulation, so you can probably just describe, a sentence or 2. You could probably write, 20 pages on that if you wanted to, but don't do that, is what I'm saying. Sentence or 2. Most likely, you're probably going to end up having to use more than 2 sentences, I think, probably to get all the words out. You can write, let's say, abstraction, space, a little definition of it, polymorphism, space. It's not an essay. That's the CSLO essay that I'm going to describe next. This is just a fill-in-the-blank kind of thing. Give me some answers. You're going to see, if you go through the lecture I went through last week, which was the review for the midterm, you're going to see all of the concepts presented, not in the same level of detail to answer these, because that's basically just an overview, high-level overview. In here, you're going to get more specific questions in terms of, what's an instance method, what is a class method. I talked about both the instance versus class method and data member or fields. Overridden, what is an overridden method in Java? I don't want you to send me an email and say, what does overridden mean? That's not the... I purposely use the vocabulary in the questions to kind of get you to start thinking in terms of those terminologies that you should be familiar with. So it's 15 questions, obviously, so 1 point each. If you don't like one, don't answer it. It's just 1 point. It's no big deal. But I would answer all of them. And here where you see an object is composed of identity, state, and behaviors, give an example of identity, state, and behaviors. If you weren't here last week, you didn't get that lecture that I gave you on the overview, how to put the pieces together, object orientation, that's the first time I actually referred to it as identity, state, and behavior. So when in doubt, go to the lecture I did last week. So was it 19? I can't remember the lecture number. I believe it was 19, but don't quote me on that. The last lecture that's listed in the lecture list. Okay, and that was section number 1. Section number 2 here, we have answer the following questions with Java source code. Here I don't want you to put words in. Lo and behold, someone's going to mix them around. Someone's going to give me source code for the first one, and they're going to write for the second one. But don't do that. What you're going to do is you're going to show with Java source code how to inherit one class from another. This is question number 1. There's 4 questions. They're both worth, all of them are worth 1 point each. You can probably do the math yourself. So, you could get carried away. You could write a full application. I don't want you to. Minimize it, strip it out. If you can't come up with your own example and you're cutting and pasting something off of the internet, please edit it. So make it as small as possible in terms of demonstrating the point.
Writing the syntax?
Yeah.
That's it.
You're writing the syntax and you're making it bare bone is what the point is. So in terms of here, how to inherit one class from another, you could say class 1 or base, you know, a couple of, you don't have to put in all the data members and all the member functions. You don't have to make a functional program out of this, is what I'm saying. And then underneath, you know, class B inherits A, extends A, you know, and you basically go through the lecture slides that on inheritance, and you'll see some examples in the lectures. It's kind of trivial if you just cut and paste. I would rather have you write your own, but don't go into an elaborate explanation because, again, you could probably write a lot of source code for every one of these. Then, you know, the second one, create and use an abstract class. Don't put a bunch of abstract stuff in there. Just put a couple little things in there if you want. Also here, create and use an interface class. Same kind of concept. In fact, the level of detail that's in the lecture slides is sufficient, but it's too easy to cut and paste SF. You know, you probably learn more. In fact, the purpose of this midterm is actually as an exercise or drill to actually have you go through, think about the concepts, write some sample stuff, implement it. So you'll get more out of it if you actually kind of write it yourself. And show with the Java source code a subclass and overload a constructor of a superclass. That's the hardest one, I think, actually, out of all 4. So section number 3 is worth 6 points. This is miscellaneous Java concept questions, where you're going to be shown some source code, and you'll have to answer some questions about the source code. And one thing to tell you is that, you know, all of the programs that you're going to see are going to compile and run just fine. If you cut and paste it and put it into a text file, don't try to compile the Word file. No one's going to do that, I hope. Put into a text file, Java C, Java, run it, compile it, run it. You're going to see the output. But all the questions are going to ask you, why? So if you can't figure out the output of the program, step number 1, cut and paste it, put it into a text file, compile and run it, and then try to figure out why. If you just give me the answer, what I don't want you to do is say, for example here, what will be the output of the following program? You just say 1, 2. There's multiple parts to it. It says explain why. So you can cut and paste and compile and put it in, see what the output is, but explain why you get what you see, actually, which is the more important than, because I know you can cut and paste. It's more than just figuring out what the output is. So here's the, a program. You'll notice it's color-coded. Don't worry about it. In fact, this was taken from Eclipse. No, maybe JGrasp. I don't know, maybe JGrasp or Eclipse. Color coding is pretty simple. Don't worry about the color coding. It's not part of anything that has to do with any, and the syntax is legitimate, valid syntax. And down here, yes, this is a hint. Yes, I mean to repeat it here. So I try to make it as easy as possible. This is going to tell you why. It's because when you make that second instance, it's going to do something interesting that you probably can't predict by looking at it, actually. So that's why if you can't figure it out, don't feel stupid if you can't figure it out what the catch is while looking at the code. And you might have to run it, actually, to see what I'm talking about. But each one of them is actually kind of unique. And, well, especially that first one is going to blow you away a little bit. First one's kind of tricky, I will actually mention. Okay, so the second one is assuming that you have a weather class and it's stored in a file called weather.java. When you cut and paste this, put it in the right files. Otherwise, the files aren't going to compile for you. So cut and paste the class for weather, put it in weather.java. Put in problem2 class, put it in that class. It'll compile and run just fine. And then at the bottom of it, you have 3 parts to it. That is going to say, you know, what is the output produced by executing the following code segment. This is not in this example. Unless it's in the, hold on one second, let me just make sure. Nope, it's not in here. So this is extra code that you would run. Because what it's going to end up happening, that's not in there. Yeah, no, it's not in there. So you would actually have to take at this point and modify what you just put together. Which is why I'm saying it's okay to cut and paste and put this stuff into files and play with it, because you're going to have to for this one, unless you can predict ahead of time. But some of the behavior is actually kind of non-predictable. But this is actually fairly straightforward, this one, but it requires you to type in a few statements to make a few things. The last question here, and in this particular section, each one of these is worth 6 points. There's 3 questions. They're 2 points each, so they're a little bit more significant because they're harder questions. Not harder questions, they're more time consuming. The last question on here is kind of an abstract question. It wants you to take and create a bunch of classes from an example problem description that you're given for a refrigerator. And list at least one responsibility for each one of the classes. And a little caveat I should mention on here, you don't need to actually create the classes. You don't have to implement this program. What I want to do is see if you can actually take a textual description and pull out a list of candidate classes that you might want to create for it. You don't actually have to, and don't spend the time to write the classes. Make a list of them, and you can actually kind of, talk about the responsibilities, maybe talk about the states, maybe associated with each one of them. And you don't have to use UML either. You can use any notation that you want to describe this. It doesn't say in the problem description to use UML, to use a class diagram, to use anything. But some of you might actually know that stuff. And if it's easier for you to put it into a UML class diagram, do it. And then cut and paste and put it in there. Post it together. I want all of the answers actually in one Word file that is uploaded or submitted into the ITU EMS. And right now, and actually my TA should probably take note of this, I'm thinking, well, this is March something, right? This is what, March 14th? Good. I was thinking about April 16th, tax day. What is that, April 16th or 15th? The day our taxes are due in this country. April 16th? Is it 15th or 16th? Let's make it the 17th and the Sunday after that. So you have all the way through tax season. So if you do your taxes, if you pay taxes, you may not actually. I mean, you might not have any income in the U.S. You may not actually process it, but all the Americans are going to be busy paying their taxes by that deadline. So you guys can busy be doing your midterm by that deadline. And that deadline is approximately a month from today. And it's not bad, actually. 1 month, 4 weeks, you should be able to do this, hopefully. And we want this in here because we want to make sure our ITU system is working for uploading assignments. It cannot be emailed to me or the TAs. It has to be uploaded into the ITU-MS. If you look for it today, there's no link. The link will be created this week. If you have problems, email the TAs. Don't email me. Email the TAs. All right, you can email me. But let me know what the problem is, what error message you get, something like that, because so we can tweak out everything so that by the end of the term, everything is flowing smoothly, hopefully, with all the uploads of all the assignments. And then we have something to grade so we don't have to wait until the end of the term. And hopefully you're working on your assignments. I'm going to talk about assignment number 2 and number 3 today as well. Any questions on the midterm? Nope. I never. Make sure to sign the roster that's going around if you just came in. Yes, please do not send assignments to the TAs. it only clogs up the email system because they can't actually upload it for you. You are the only one who can actually access your account to upload the assignment, and we can't accept it if it's sent via email. It can only be accepted through the ITU EMS. It makes no sense to send it to the TA. Okay, so if there aren't any questions about the midterm, we'll move right along to the CSLO essay. You're going to love this one. I know, half of you are going, what? Let's just minimize this then. I don't want to save it. Oh, what is this? Not now. Okay. Forget everything you ever heard about CSLOs from previous terms. Not your concern. Let's make this a little bigger. What does CSLO stand for? It stands for Course Student Learning. And I changed it. Instead of objective essay, now it's essay. So this is forget everything you ever knew about CSLOs. Starting this term, we're allowed to actually come up with our own concept of the concept of the concept, and implement our own concept of the concept of the concept. And the concept is, for my particular interpretation of the concept, is that everything in this class we're doing is hopefully Java related. Writing source code, answering questions about source code, answering questions about how to implement this program idea, UML. We haven't even gotten to that yet. And we'll be covering UML actually pretty soon. It's all technical, hands-on. This is a graduate level course in which after you graduate, especially from an American university, you should have some English writing skills. And technical writing skills, in my opinion, which means it's a little different than writing Mary Had a Little Lamb. It's more along the lines of trying to explain concepts in English, which you all know. However, if I queried anyone in this room, I'd say you probably would need some help with your communication writing skills, which is the purpose and design of this particular essay. It's an essay. It's a writing assignment. And in the writing assignment, it's also going to test your research skills. Because different from the previous CSLOs, I don't want to hear about your feelings. And I don't want to know about how you learned how to figure out how to write a Java program. And how does it make you feel to write a Java program and all that other stuff. Instead, I've got some options for you. So you can select each one of this, and actually if you're taking multiple classes from me, know that this is going to be the same identical format for everything. Different questions, but the same information is going to apply across the board. Each one of them has 5 questions. You answer one question, so you pick which one you like the best, depending upon your interests. And you're writing a 3 to 5 page double-spaced essay. So 3 pages and 1.5 page single-spaced, but I want it double-spaced. And you will be graded on your English language skills and your writing skills and your research and your presentation of the material. I will warn you about that. So the midterm, I don't care about your grammar, your spelling, your punctuation, or your comprehension of anything. It's did you give me the right answer. Here it's all about the presentation. So what you want to do is you're going to take and select a topic, one of the 5, so you're not forced to write on a particular topic you may not like. You must include at least 3 reference citations. Maybe you guys can see this. Maybe, I don't know, hopefully it's big enough for you guys to read. It's in the assignment description, actually, so you can read it at the top. Yes, 3 reference citations, which means at the end you're going to have a reference list. This is like preparation for writing a journal article, a magazine article, trade, something that you would do professionally for your company, for something writing related. You could actually kind of treat it like a technical writing kind of exercise as well. 3 is not that bad, so you find 3 sources of information. A book, a journal article. Make sure they're professional sources. I don't want you to quote Wikipedia. Or you can use online sources. We do have access to a library, to the San Jose State University Library. You can use that. We also have an internet available to us that is full of information, full of databases. Make sure it's a reliable source, and make sure it's not something that is for a company. So you go and you search on some of these topics, and you'll see, you know, Oracle company, not Oracle, I don't know, Sun, or some company is doing something. And depending upon which question you ask, that may or may not be appropriate. If it's going to be simply theoretical, because you have some options with the selections, you can, and I'll walk through each one of the selections and describe those to you. You can kind of talk theoretically, or you can talk case study, business example, project example. And depending upon what you're doing, some source might be more appropriate than another. So that's why I just put 3 reference citations. It doesn't have to come out of published journals. Just don't use Wikipedia or, you know, cut and paste and give me stuff off the internet. I want it actually referenced. So if you're using something within the text, you have to provide an in-text citation. You know, it's like, so-and-so from Oracle said such and such. You know, last name, comma, the date. You can use APA, MLA, Little Brown Book, anything you happen to be familiar with. I'm not requiring any particular format. If you're not familiar with reference citations, APA, and if you go to www.apa.org, or if you search on APA writing style, it's A as in apple, P as in Paul, A as in apple, it's probably the most popular one used these days in American universities because it's easier. Some people find it easier than MLA or some of the other ones. Yeah, it originally started out as a writing format for psychological papers, liberal arts, but it actually kind of works well in terms of modifications of it work well. I want you to present it like a formal paper. So I'd like, you know, putting a title page on there, putting a running header maybe, some page numbers, double space it, present it well, type it well in your word processor, you know. And you don't have to print it out, you can submit it electronically just like everything else is. But what you're trying to do is make it look as good as you want. Your paper must reflect your own writing and cannot contain portions of cut and pasted material from the internet or other sources. If you cut and pasted, and I think I have the caveats in here somewhere, if you receive 0 credit on the assignment, you're going to automatically get a 0 because if we run it through turnitin.com, and I actually have another one I'm going to run it through as well, to check for plagiarism. So not only do you have to write it yourself, it has to pass our plagiarism exam, or plagiarism checks. Which means in Turnitin is actually kind of good. In fact, I'm going to use Turnitin because what that does is as soon as you submit a paper to it, it stays in the database. So if 2 of you have like the same paper, the Turnitin is going to tell us that. And then, you know, it also like picks other sources from other classes that are here, from other universities, from this whole database. So it's kind of a separate database tool. Some of you may or may not be familiar with it. There's nothing that you have to do for it. All you have to do is give us the assignment. We take the assignment and we'll run it through the database check, and I'll show you guys how to do it, actually. In fact, it's a free tool, not free tool, it's a tool in which ITU has subscribed to. It's a service, actually, that we're encouraged to start using, essentially. All right, so if you've cut and pasted it from the internet, all of the papers are going to be processed through turnitin.com for plagiarism detection, and your paper ends up being plagiarized, or it's not your own original work. It was turned in by somebody else in the class. And the good thing for this class is this is the first time I've ever given this assignment. Nobody from last semester has turned this paper in yet, which is good for you. Okay, so you're going to receive 0 credit on the assignment. There's absolutely no makeup for that. That's going to reduce your score significantly, considering the fact that this assignment is worth 25 points out of 100. If you get a 0, it's automatically a C+ in this course, 75%. Doesn't matter how well your Java programming is. You're going to end it with a C+ in this course, and we will give you a C+ in this course. No grade change. So it's kind of like encouragement, hopefully, for you to actually take and use this as a way of practicing your writing skills. So in terms of the content, because that was all about the mechanics of the paper, and you know, we're not going to mark points off if you used MLA versus APA versus anything else, or if you use something else, or a combination of something else. The idea is to get you some practice using something, and to actually have you write it yourself. Okay, here's our topic selections, and what I've done is kind of like try to highlight in a different font the theme of each one of these questions. So you can kind of quickly look at it and go, well, what am I interested in doing? You have to pick one of the 5. I don't want a paper on a different topic. But you have freedom of interpretation on the 1 through 5. As an example, the first one, actually I'll just go through all 5, and it's not too bad. You want to provide an overview of the concept of object-oriented modeling. So, also discuss the concept related to object orientation and provide some examples to demonstrate your points. So, object modeling. You could cover, in that particular question, if you're doing an overview, you can cover UML, actually. You could cover object whatever, object this, object that. You don't actually have to cover any particular design theory. You could talk about object modeling in general, the concept of the hierarchy. This is a Java class, so you probably want to talk about it related to Java, but the question doesn't require that either. You could talk about it like the generic object modeling concept and how we're taking the real world and turning it into objects. You're probably not going to get 2.5, excuse me, 3, a page and a half single spaced out of that, 3 pages double. So you probably have to elaborate a little bit more on it. But feel free to go off on any tangent that you want. You have the freedom to interpret that because it's kind of generic, the concept of object-oriented modeling. Well, it's object-oriented theories. So you can talk about reuse, you could talk about hierarchies, you could talk about the object concept, where it came from, where it originated from. You could talk about the history of object-oriented concepts if you wanted to, or the future of it. But it's on the major concept. And so what I've done is I've kind of changed the words here to highlight the fun to say concept of object-oriented modeling, which means that's kind of the theme of that first particular question. And then the second one, and stop me if anyone has any questions as I go through this. I'm going to assume it's either you're sleeping because it's an hour early, or not really. You should be awake at that point, or you understand all this. The second one is about the use of Java as a web-based application tool and as a cross-platform programming language. So you could actually focus on the web-based application tool and say in just a couple lines, not very much about the cross-platform, or you could focus completely on the cross-platform development idea and provide some example benefits, and a general discussion of how the cross-platform technology works. You know, depending upon the level of technical detail that you know about it, may also be a source of some research that you might be able to perform on that to describe the process. If you start describing a process, unless, you know, it sounds like you have known this for your entire life, and it's something that's well known, you don't have to reference it. If you start going through the object cross-platform documentation for Java, which you'll find a lot actually. There's like 300 or 400 page documents that describe the cross-platform capabilities in the model and how enterprise EE development works with that. But this isn't really an enterprise edition question. This is just a generic question. But again, you can go off on different tangents if you want in terms of that. The next one is the EE question, actually. And now we're going to talk, we haven't gotten there yet, but we're slowly getting into, after today we're going to talk about containments, collections. We're going to talk about collections now. What are we talking about today? Collections. Next week we're talking about I/O, exception handling, stuff like that. And then we're going to go into graphics, swing, and applets, and webs-related technologies, which we haven't gotten there yet, and mix in a little UML stuff towards the end. So we're halfway through the course. We haven't gotten all of the information, but you don't actually have to use information that was presented in this course. If you wanted to start and write this early, you could actually, probably answer the first question. I don't know. You could probably, or research on your own. You don't have to rely upon the course materials, is what I'm saying. And just as a side note, because I did not mention it, this is not due on April 17th. This is due the very last day of the class. You have the entire class to work on this, but I'd like to make it available now. And it's available at the same time as the midterm, so you can kind of start working on it, and it doesn't show up as a surprise towards the end. And we'll also make the links at the same time in the ITUMS, so you'll be able to upload it whenever you have it ready. If you're planning out your schedule, you probably could do both before the, by the 5th, April 15th, 16th, but this one's not due till the very last day. But it's food for thought, because then you can start thinking about, well, which one of these do I want to do it on? So, all right, so that was number 2. Number 3, discuss the growing importance of client-server computing, and provide an overview of the Java enterprise environments in terms of how it works with the client-server computing environment. So you can focus on the Java client-server computing, how the objects, remote objects, which would basically be the theme for that one probably. So, if you don't know anything about client-server, you don't have to worry about it. You don't have to pick that one. You pick one of the other ones that you do know about. Number 4th, I've kind of highlighted, and this one I got client-server computing highlighted. I probably could have highlighted EE, Java Enterprise Edition, but here, now I got the standard generic question that comes out on almost every exam and almost every assignment you see for every course in Java. Compare Java with another programming language. Don't recycle. Don't go on the internet, because I already told you already, you're going to get 0.75. You're going to get C+ in the course. If you do this, don't go on the internet, because you'll find dozens of papers on comparing. In fact, you'll probably find dozens of papers on all these other subjects as well. But this one in particular is very popular. But if this is your first Java course, you're a business major, you're switching in, maybe you're an engineering management person now, and you're taking technical courses along with business courses, and you're kind of crossing over, this is a new question for you haven't seen before. Answer it. It's probably the easiest one on the page. But it doesn't mean because you answered this one, you're not going to get as many points, or it's not going to look as good either. This is what's called the student learning essay, which means each student gets to show me what they've learned depending upon what they in particular have focused on in terms of their essay, in terms of their topic that they selected. It's not an assessment of the entire course, it's just you as an individual showing me that you've learned something about object-oriented design in Java, essentially. Alright, so yeah, the stando de facto, compare Java as an object-oriented language with another object-oriented program. Don't compare it to a non-object-oriented language. Otherwise, you're answering question number 1, which is tell me about object orientation. So did you set your alarm? I mean, your clock back? Forward? Spring forward. I'm just picking on you. A lot of people, everyone's going to show up an hour after the class starts. Okay. Well, some people were working too. So. All right, so I'm going to assume you know what I'm talking about in terms of that question. If you don't, this is your opportunity to compare Java with another object-oriented programming language. There's one language that supports something. In fact, if you're actually a computer science kind of person and you're doing this one, I'd focus on the object-oriented features. Like C++ and Java are completely different in terms of their interpretation of inheritance, the interpretation, how do you do multiple line inheritance? Is it supported? Even the concept of abstraction is treated differently as well. So there's a lot of things about object orientation you could compare and make it actually quite interesting. And last but not least, number 5, demonstrate how to solve a given application problem. By going through the steps, the basic steps of the program design within the context of the object-oriented design methodologies. You do not need to create the Java source code, but you want to provide the logic for the program design, explain why it's a good design, and how the object-oriented concepts are applied. So what you're doing essentially is describing in words, because what I don't want you to do for number 5 is give me a program. This is not, that's why I said the word essay on the top here. This is not a programming assignment. Don't give me source code for any one of these examples. You can, however, provide little things like, this is how we inherit in Java. This is how we inherit in C++. But keep it to a minimum. Don't write programs and don't write source code for this particular assignment. And when you demonstrate it, what you want to do is solve the problem. Kind of like if you were here a few minutes ago and I talked about the midterm. The last question is describing a refrigerator application and building the class hierarchy. If you want to, in fact, number 5 is the cop-out. At the end, I said, well, let me give you one for people who just don't like to write. If you really just don't like to write, number 5 is pretty easy because you can just describe the UML process of you can describe an application, design, You can create the classes, show the class list, describe, the hierarchy, describe how you would put it together. And it's kind of like number 5 on the midterm. It's kind of like the last question on the midterm, as you're describing an application. It's a little easier. In this particular case, you still have to find 3 references. So in terms of the techniques, you might want to, let's say if you're doing, UML design on it, and you're going to say, solve a problem of the application, the application design, you could quote, let's say, the source of the problem. Say, it came from this company, and they need a system that's going to do this, and use that as a reference, and then maybe something about the design methodology as another reference, and then something else as another reference. The point is, you can't turn number 5 into a source code regurgitation. It's not show and tell. I don't want to see your source code. I'm not interested in any of your technical source code writing abilities. What I want you to do is solve a problem, solve a given problem. If you don't like that one, it's kind of an abstract kind of question, pick one of the other ones. That's my recommendation. Any questions about the CSLO essay? Not due until the very last day of the class, the day of the final exam. Well, unless you're taking the final exam early, and then it's due the very last day of the class. No. Good deal. And no questions now, but just wait. Okay, I thought that I had covered the second assignment, but I'm told I didn't. So let's talk about assignment number 2, then we'll talk about assignment number 3, then we'll talk about first part of the collection. What can I say? I want to say containment. It's collection. Because I'm thinking about a container is what I'm thinking about it. So it's a collection, the collection concept that we're going to get into today. All right, so here's assignment number 2. And you know what it is? I probably went over it. I think I did go over it for the weekend section of the class. That's probably why I remember this. But I didn't go over it for you guys. But you should have already done, hopefully, assignment number 1. Most of you hopefully should have done assignment number 2, or you should be thinking about it. It's actually not too bad. It works with the concept of inheritance. So number 1 was the object concept, a little bit more complicated than Hello World, but it was very close. Number 2 has you build a hierarchy of classes. So what you want to do is ITU wants you to write some classes for their personal record system. And to make it simple, consider only 4 classes. We have person, employee, instructor, and student. If you remember, a couple weeks back when I was talking about inheritance, a few weeks back by now I think, I actually gave you person or employee, staff, or something. I actually gave you kind of a working structure to start from if you wanted to use that. It's on the bhacker.com website, actually. It's also in a couple of the YouTube tutorials that I put together, which I have to catch up on. I have to finish some of those. But anyway, you're following this picture right here that illustrates the concept, and the picture's got person on the top, a person. Then we have, from that, we have an employee and a student, because employees and students are both instances or objects of person, hopefully. And we're not robots, hopefully. And then from an employee, we have instructor, we could have TA, because a TA is an employee, which is also a person. We could have front desk person, we could have, anyone who works at ITU would fall under that category. So the employee class and its parent class is illustrated here. And the parent class, the employee class is the parent class of the instructor class, as we see here. So if you just don't even read the description, you just look at the picture, you kind of get what you're building, I hope. So the following are the tasks you need to complete for each one of these classes, and you're building 1, 2, 3, 4 classes. So you're going to write 4 classes, and you could probably put together a little driver program if you want to test the classes. In fact, I think that's part of it towards the end, but let me refresh my memory in a few minutes. So the following is what you have to do. Create the appropriate fields, data members, fields or data members, for each class. Necessary fields are listed. Add your own fields if you need it, so you can add whatever it is you want to it. Some fields need to have appropriate constraints to it. Constraints would be, private, public, would also be, if it's an array, it goes up to a certain level. It's of a certain data type, stuff like that. It's a string, it's a double. Use your own way to make sure that these constraints are satisfied. And here we have a person. So a person has an ID that's an integer starting from 1 and should be unique. So right there, hint, hint, start looking at static, start looking at class level fields, because that's how you're going to put the constraint in. Because if each person that gets created as an object of person, you can have a counter for the person object at a class level and increment the counter on each new instance of each new person that gets created. Now, I gave that one away. I'm not going to give the rest of them away. But that's what I mean by constraint. You can implement it in any way that you want. Here, the constraint is, starting from number 1, we have to have an integer. It has to be unique. Well, how are you going to make them unique? So that's one approach to implement that particular kind of constraint that's being asked for. So look up class variables if you're not understanding what I'm saying. The employee's salary has to be double, should not be negative. That one you could probably just put right there in the source code, I think, actually. The student, for simplicity, assume that the student has at most 1 teacher. So we don't actually have to create a sophisticated list of teachers. Just say it, assume that at most 1 teacher, which means they're going to have 1 teacher. Just fix it to 1 teacher if you want. The teacher ID is an integer as well. And his or her instructor ID, 0 if no instructor is given. This is for the student. We have the teacher ID that's associated with this, the student's teacher. And then we have the teacher's name, which is a string. And then we have the instructor. These are the different classes, by the way, 1, 2, 3, 4. Instructor, we've got a student ID array, because we have 1 teacher for 1 student. Well, each student has 1 teacher, but the teacher might have an array, might have a group of different students, hopefully, that are taking a class from the teacher. So you have to figure out how to do an integer array, which, if you don't know yet, the Deedle and Deedle text will show you how to create an array. And an array is nothing more than a multi-valued variable. So instead of having 1 string, you have 10 strings for 10 names or 10 IDs. So the array of student IDs of this the instructors of this instructor, the students that belong to the instructor, and set the array size to be 10, which is good because now we're limiting the number of students. So each class only has 10 students in it, essentially. Initially all zeros, assuming that an instructor won't have more than 10 students. So create the array, initialize them all to 0. Go ahead and set forth, Which kind of, at this point, can tell you that we're sharing some information, because teachers know about students. They have 10 of them. Students know about teachers. So we're passing some information between the objects. A student gets created, gets assigned a teacher. The teacher needs to know about the student, because they need to know it's enrolled. The student needs to know which teacher they've been assigned to. So we've got some information going on that's going back and forth between the different objects. So it's actually kind of showing you how to communicate between the objects as well. All of the above fields are private, as I've been, and I want to use the word beating into you so far. Private, private, private. There's one more beating. So, reiterating the point. Let's talk about iteration today. So, today's theme is iteration, if I ever get there. All right, so they should be private, and they're only accessible through the access methods. Those are the methods inside of the class. The accessors, the ones that are accessing the private data members. Hopefully you get that point. A toString method for each class to print out all of the available information about the current object. If the person class toString is declared as abstract. Oh, in the person class, toString is declared as abstract. So that tells you that's going to be an abstract class, by the way. A static finds students, and it's giving you the syntax for the method, which we've got here. In the instructor method, to fill an instructor object students. You can have this go as a separate method. You can have it go from a constructor, have the constructor call the method. So we have a new student, we have a teacher, and we want to go, let's say we want to find all the students. Because Maybe we created the students after the teacher. Maybe we created, depending upon the order. This is where you have academic freedom and kind of interpret how you want this world to exist. How you want to, how do you want your objects. The order in which your objects are going to come into existence might affect your design in terms of how you want to create things. A person should be declared as an abstract class. Actually, I sort of gave that away already with the abstract method. Provide multiple constructors, methods if needed. You don't have to go through. The first assignment had you to create like 4 or 5 constructors. It was more of a routine of an exercise to get you to create some constructors. Here, just create what you need. The purpose of this assignment is functionality and not necessarily paperwork. I mean, it's not writing. It's not a writing exercise. It's not, give me 5 constructors. Just give me 1 or 2, whatever you need. Check the test.java program below to see that constructor methods are necessary. See what's necessary and what actions you should do. Below there's a driver program called test.java. If your program works with it, great. If you have to modify test.java, you have the academic freedom to do that as well. If you want to change, you don't like the design of that test program, and you want to have different constructor behavior, go for it. You want to change the order of something or make something clear, you can do that as well. Make sure the test.java program can work with your class. And again, modify the test.java program if it doesn't work with your class. But hopefully you'll start with the test.java. The harder thing to do is to start with the test and move and create the classes to work with the test. It's easy just to change the test program, but don't remove the functionality of the test program. Test program should still be making objects and still be working as it's supposed to. Because you can't turn test into hello world, and that's not going to cut it. Alright, so see the sample output below. And from the sample output, you'll know what information you're going to need to print out for each one of the specific objects that you create. Note the sample output is not the unique output format for the test program. The real output format depends on how you design your toString. So you have some freedom to design that method as well. Some hints: there's no main method in any of your 4 classes. We're using inheritance. And to make sure the ID is unique, across the objects declare a static last ID in the person class. Static is going to make it into a class variable. Read descriptions in test.java, very careful for better understandings. Submit your person.java, employee.java, student.java, instructor.java files. If you've changed the test.java, submit that one as well. If it's not, you don't have to submit it. Make sure to zip them all together into one file, please. If you start uploading one file, you're going to end up with a problem because it's not going to let you put in the rest of them. So put them all into one. Here's the test program. It's kind of small, actually. It's just making some instances of your objects. But it's going to show you, like, person's going to need to take a name, let's say, for example, as a default constructor. So build the, yeah, I was actually standing in front of the projector there. Build the class interface to match the test and how it's being used. And it's pretty simple, though. You see some notes in there, and then at the bottom you should see the sample output here as well. So I'm going to save you the boredom and not go through the entire test program. I'll leave you that for you to do. But generally you end up with a situation where you're given a program and you have to create a class that doesn't exist. So this is not a bad exercise in being able to actually create classes that are going to work with this. If you do this in a project structure, I don't need your project files, because theoretically your Java files should be all that I need to run this. So if you're using Eclipse, if it's easier for you to just take and zip up the package directory, or zip up whatever it is you want to zip up, do it that way. Otherwise, just the Java files is what I need. I don't need class files. I don't need anything else associated with this. Questions on assignment number 2? Nope. This one you should be able to do, actually. We've covered all of the material for it already. Moving right along to assignment number 3. This is the new material that we haven't, small. This is the new material that we haven't seen yet that I'm gonna start in on today. I'll maybe get through the first couple of slides, actually. Next week I'll finish the slides on it, depending upon how far I get, and I'll have some source code examples for you. Assignment number 3 out on the bhacker.com website, you might notice if it's still up and running. Let's see if it's still working. If it runs kind of slow, it means it's going to probably fail. Oh, no, it's actually working. Let's see it down here. This might actually load. Yep, it's almost there. Still working on the issue, obviously. It's kind of touch and go whether it's actually going to load, actually. Let's see. If this doesn't fix itself in the next week or so, and if I run into another problem with the database, I'll move it out to an HTML format. So the problem with this is it's using a database right now, and the database, for those of you who came in late, the database is having a meltdown right now. It's an old system, and the board's all dusty, and the fan's clogged up and stopped working, and something is overheating. There's a fan on it right now, cooling it down, but it doesn't appear to be working. All right, so it's not gonna perform for me right now. So when you look at the assignment, you'll see assignment 3 -hashmap something else something. All those files go together. They're all talked about in the description. If you download and you look at assignment number 3, it's going to essentially give you the instructions that you're going to need to assemble this. So you're given some pieces that you can work with and extend from, and you're implementing a concept. And you probably wonder, a concept we haven't even talked about yet, but we're going to start talking about today, and I'll introduce it to you. And we'll finish up next week. So this one you may not be able to do right now. So don't start on this one first. To the midterm if you're looking for something to do. And there's 2 exercises, 2 separate programs that you're writing for this. The first one, it's your goal is to extend the Java-defined HashMap class. And it's going to add the ability to store multiple objects to this, and you're going to edit multiple hashmap.java, which is given for you on the website. So whenever it says something .java, look for it. It's in the website with the support files that go along with the assignment. To both, you want to add a new method and override 2 existing methods from the hash map. So what are we looking at? We're actually talking about a collection concept where we've got a list of items, more than a list. We've got the physical items being housed inside of another item. You kind of think of it sort of like a list, a dictionary, a hash table, something in which we have an association that's occurring between a main object and sub-objects that are parts of it. So we have stuff like iteration to think about here. How are we going to go through the list? How are we going to sort the list? How are we going to keep track of who's in the list? Add an item to the list, take an item away from the list. We actually have built-in support in the Java language. If you're a C++ programmer and you're sitting here listening to me, you're probably going, this sounds like data structures. It does. If you remember linked list, they taught C++ linked list as a way of introducing pointers. Or some instructors actually use that as a means. Because in a linked list, you have nodes that are part of a tree or part of a list. So you have a list and you have a list link, list nodes. And the nodes are keeping track of data elements that are connected together, and each element knows of the next element. So the way that the linked list actually works, if you're not familiar with the concept, it's all pointer based. So you have the memory, you create an object and you get its memory address. And then you tell that object who's next to it, either from the right or from the left, either before or in front of it. And you give that object that memory address too. And then you can kind of jump from one object, follow it to the next object, follow it to the next object, follow it to the next one, and you know how many is in the link. Or excuse me, how many is in the link, how many is in the list, because they're all linked together using memory addresses. We don't have pointers in Java. Instead, we have built-in support in the language to support collections. The collection object, in fact, we have a whole hierarchy of interfaces and abstract classes that support it. It's given to us, we just have to figure out how to use it. So the point of this exercise is not to reinvent the wheel, but to use what already exists in the language in terms of its capabilities. So as an example, you're going to need to implement 4 new methods. See the details in multi-hashmap.java, which is going to give you, this is the main file that you'll be working with for exercise number 1. you're implementing methods that are going to work with the objects. And the objects are going to, the methods are going to get all the objects, put all the objects here. What does this object contain? Remove an object. Because what ends up happening when you start creating these things like linked lists, and I don't want to call it a linked list because it really isn't. That's a C++ term. It's, or data structure, general structure kind of terminology. It's more referred to as a collection. So inside of these collections, you build method behaviors to sort the items, search an item, get an item, put an item, all the functionality. So what you're doing essentially, and I'm going to give you a high-level overview, and then next week we'll look at it again. We'll look at this assignment again so that we can actually because now you'll know what I'm talking about, hopefully, after a couple of slides of the lecture. And then we'll figure out what are we actually supposed to do. What I'm going to put together for you, actually have it together, but I can't get at it because it's on the bhacker.org website. But not working right now, is an example that kind of mimics what it is we're building here. It's not going to do everything, because that would take away all the learning experience. But it's going to represent at least the concept to you so you understand what it is that you're building, what you're working with. Because once you understand the concept, the rest of it is kind of easy. It is a bit tricky, though, I will warn you. Of all of the assignments, this is probably the worst one. This is the hardest one. But every time I say that, people go, oh, no. You should be lucky, though. Each one of these assignments is only worth like 5 points or something, right? So if you don't do this one, you get a 95, you can still get an A in the class if you don't turn this assignment in at all. So that's motivation for you not to do it, I guess. So, all right, number 3, you need to override 2 methods, and it means give it same signature. We know what a signature is already, right? Yeah, same format, same number of parameters, same return type, override the get and the put, essentially. And then you're going to extend the behavior. You're going to do a few things to it. You're going to test the implementation, compile, and run it. And we're giving you the test hash map test file, so you don't actually have to write the driver program either. There's not too much coding, actually, for this one. Less than the previous one. This is more along the lines of understanding the concept, actually. Because what C++ people want to do is start looking at pointers and memory addresses and stuff, because that's how you implemented the concept in that language. People without any Java experience or C++ experience or anything at all are looking at this going, how do you put a collection? How do you put an object inside of an object? And how do you organize the collection? Which is probably an easier approach to it because we're given the tools in Java. So it's a little bit easier, actually. And we're actually going to look at thread programming as well at the same time. And you see, if you're a C++ programmer and someone said threads to you, you're like, oh my god, you want me to use threads? That was a nightmare implementation. You had to actually create a thread, fork something, and then you had to have, it was communication going back and forth, and if this process dies, does it go back up to this process, and the whole hierarchy? Now, in Java, it's a cinch, actually. It's using a word called synchronize. And now you've got inter-process communication, and synchronization is built into the language for you. Thread processing is built in. We can still create threads and run them, but it's a lot easier. The support is there in Java. It's not there in C++. So you could actually kind of consider Java as an upgrade to all of that C++ stuff. None of it's done manually anymore. So anyway, I'm going to revisit this another time when after we start looking at collections concept and we see another example. But essentially, you're following a driver program that's written for you. You're implementing the functionality that's requested, and then you're taking this and you're going through some scenarios. Suppose that the test object is an object of this class. It contains no key pairs initially. Here's some functionality to kind of consider. And you're given some hints on the end. Iteration cannot guarantee the order of the object's returns. You have to have the object self-identified or numbered somehow. And then that's where you actually start looking at, class-level variables and how that stuff works. So you're looking at instance versus class in this assignment again. You're looking at inheritance. Not really. Not really. You're looking at enclosing one object inside of the other object, keeping track of objects, and using the built-in utilities of Java. So this is the first assignment that's actually going to have you use some features of Java that you haven't probably seen yet. So the next one is you're just doing your sorting made easy. It's a totally different assignment, not associated with the first one, but it's on the same lines. So you're using the java.collections, utilities collections, and this is different than the util collection. And what we're looking at here is looking at lists, sorting and searching lists, and list processing, and doing binary search. So in this exercise, you're going to utilize collections.sort. So we're going to look at some other built-in features, and I'm going to save that one for the next time I look at this assignment, because this one is a little tricky. But you're not going to get half of it until I start talking about collections. So, but that's a preview. Let's call it a preview. I'll revisit that as well. And I know I've already talked for an hour or so. So I just want to introduce to you the concept so that you know what we're going to talk about next week. Well, that and I'm going to start it. So this is lecture 6. And lecture 6, hopefully it's the right one, because I don't have access to, well, actually I do. I can FTP to the site. Any moment now. I thought I had this loaded. Collections! Alright, so for those of you who've been sitting here lost for this last 10 minutes or so, here, we're going to show some clarity to what I'm talking about. The concept. So a collection is a data structure, as I mentioned before. Actually, an object basically holds other objects, as I've kind of alluded to already, but you can store and organize objects in useful ways for efficient access. Why do we want to do that? Because we don't have things like dictionaries. Well, dictionary is a data structure. Hash table is data structure. Lookup table is data structure. Index is data structure. All sorts of these different things are implemented as concepts. It's just nothing more than programming that you're familiar with already. So everything is in the util package. If you go online and look at the java.util, you'll see lots of different support classes, a lot of interfaces, a lot of abstract classes that you can investigate. Here we go, a lot of interfaces and classes, providing general collection framework. So programs can provide implementation specific to your own requirements, which means here, in fact, the reason why I like this assignment is the overloading and overwriting. So you can be given something and you adapt it by overloading and overwriting. What you don't want to do is change these built-in packages. They're there for a reason. They're setting a foundation. It's part of the hierarchy. So what you're doing is building off of the hierarchy that's designed for you to implement, which is why we covered already the implementation and the concept of interfaces and abstraction and abstract classes. It's built for inheritance. So you're inheriting, you're building upon existing functionality. The overview of the interfaces and the collection classes and the collection framework is kind of below here. So here we have the collection as a concept. And hopefully you can see that's kind of on the bottom there. And I'm not standing in front of the projector, that's good. And underneath collection we have the concept of a set and the concept of a list. And we can kind of go back and kind of just think about it from a data structure's point of view. You know, the set, we're not necessarily looking at the order. It could just be items. It could have multiple items associated with it, hashes or something. So we could have like a hash set. And here we have an array list, which is that dreaded awful thing in the linked list. The dreaded awful thing we get in C++, if you've ever tried to implement one of those. The assignment that's a classical assignment, actually, if you take a C++ programming course. They always have you put together an array list or a linked list. The favorite is the linked list, because you can combine that with pointers. But not such a big deal over here as I'm talking about, so don't worry about it. The set, we could have a sorted set, we could have an unsorted set, we could have any type of set. And what we're doing is essentially building off of the concept. So we take the concept of a list as an example, and we can make any kind of list. A list of teachers, a list of students. And then we can actually kind of make functionality for what students do. A student's, teacher. If I wanted to, I could take that second assignment actually and have a student drop a teacher, change teachers, drop classes, add classes, or even add classes to the component as another component. We could have a class, and inside of the class we have a list of students. we can customize that entire data structure. In fact, call it registration. And then you can have all this functionality that's specific towards the activity of what the registration concept is talking about. Because in this, we don't have an add class, drop class method. We have to build that upon the list or upon the structure. And so here we have a map. This is more, in fact, this lecture slide set is geared towards that assignment number 3, which is like why I like to preview it first. Map, and we have sorted map, which is a tree map, which is a subset component. You know, it's built upon the map concept. Hash map, weak hash map. And then we have the concept in terms of the iterator. And the iterator, what goes through the list, iterates the list. It's like the wheel that you put all the list items on. And spin the wheel around and see which list item comes up next. So you would actually build the data structure to sort, to merge one list with another list, to take an item, and not really iteration, but to remove an item from a list, to add an item to a list, would pretty much all fall in terms of the manipulation that you would do on the built-in functionality. So what you don't want to do is start over and reinvent the wheel. Which actually I've seen a lot of programmers do. They'll come out and make a list, and then they won't use it, because you don't actually have to use any of this functionality. Just like anything else in the language, in the Java. It's there. If you don't know it's there, you don't use it. And if you don't use it, you have to reinvent it, and you have to create your own. There's more work. So the concept is kind of learn the feature, use that. So now this is the scary slide. Yeah? Yes?
Map is not part of collection itself. It's mainly set in this, but we say map is
A collection and a map and an iterator are three separate concepts, actually, that are all part of the util package. They're all providing different lines of functionality. If we think about the hierarchy of objects, we have a map object, the collection object, and an iterator object as a base class, and then we're building from it sorted maps, hash maps, unsorted, different types of maps, different types of collections, different types of iterators, and it's separated out into that abstraction. There's actually more to it. Just for object hierarchy, if you want to think of it that way. A map is actually kind of a different concept, though, from a collection. It's a map. It's like a dictionary. Like, so we take, a word. This equals another definition of the word or something, which is not necessarily a collection because we're using it differently. We have different lookup tools. We have a key and a word or something, or an item and a key, or a key and a description. We can actually create our own definition of the map as well. And a map is just a link from one to another. We can actually have 3-level maps, 4-level maps. We could have sorted maps. The concept itself is it's kind of very abstract. It's left for interpretation, and that is actually what the assignment is working off of, is the map concept. It would be way too trivial to give you because what you can do is just go on the internet. You can probably find Java linked lists all over the place. In fact, that's the most common thing you're going to run into when you start looking for examples. Because, most students actually just kind of go on the internet and say, well, I'm looking for how to add an item to a list, how to take away an item from the list, Maps they're very special purposed. And then iterators are used. So we have an iterator object. We can create a new iterator and we can, basically a listen iterator, so that if something gets put in, we can go through each one of the items and clean it up as a maintenance or something, or we can put them in alphabetical order for a binary search. And in order to actually fully comprehend a lot of these particular utilities, you almost need to have some sort of a data structures type of background, but it's not impossible. So if your data structures background is kind of limited, get the Deedle and Deedle text. He has an entire chapter on data structures. He'll go through everything from, what's a collection, what's a list, what's an iterator, what's a map, Or I should kind of recommend probably doing a little Google search, perhaps. That'll fill in the needed data structures background. In a traditional computer science kind of environment, you would, if you were, so this is really an undergraduate kind of topic actually, you would take a data structures course, maybe even a discrete math class that kind of went through like probability, statistics, as well as list concepts. Well, I mean, it's not a necessity though. In fact, a lot of programmers learn it like as they're working. You know, it's if you come from a pure business background, this is really foreign. But you know, the more you work, it kind of the data structure kind of concept overlaps. I think in a lot of different things. In fact, we see it a lot more with C++ because you can create a structure, which before we even create a class. And if you think about it, a class is in its essence, the object is a collection because it is accumulated, and it's not a, it would be more of a map. It would not be of a list variety. We don't have like a collection of list items that encompass a class. We have data members, we have member functions, we have all sorts of different pieces and components that compose that. So you might think, you know, from a C++ perspective, the structure was like the starting point for data implementations because, well, a structure, if you're not familiar, it's kind of like a class, but it doesn't have all the same inheritance, reuse, functionality. It's the C version of the class. And it was a way of creating a collection where you can put an integer, a float, a double, everything all into one. And actually, now that I'm on this tangent, I might as well go back and explain array list versus linked list. So, in terms of programming constructs, this is programming 101 now. The collection is an accumulation of assorted items, not all of the same type, not all of the same, you know, a collection might have a class in it. It might have an array. It might have a string or a variable. An array, for those of you who are not familiar with the concept, you'll need this actually for the second assignment, is a list of liked items. In almost practically every programming language out there on the market, arrays can only have, well, I shouldn't say this. Some of the internet scripting languages, you can have multiple different variables stored in the array. So like, but it's kind of the oddity for traditional style programming. And an array is a collection of liked items. So you have an array of classes. And you can stick anything in the language inside of the array. And the array is actually nothing more than a multi-valued variable that's kind of treated like a single variable, and you access each one of the items in that variable by its index number. So it's an indexed, not assorted. I mean, because, you know, you can say, you know, give me an array of 5 integers and put 5 of them in. You keep track of it, which is why they call it an array index. You keep track of it by each one of the 0 through 4, the number that it represents in your list for how you added the item. And to work with that, from a programmer's perspective, it's very strict. Most languages won't allow you to grow the array. Like 90% of the languages, when you say you want an array of 5 employees, you get an array of 5 employees. Later on, you want to add number 6? Nope, sorry, you can't add number 6. Only 5. So then other things came along, like the linked list. In terms of how the array list and the linked list differ, the linked list came around and said, well, we can create a dynamic, and some textbooks call them dynamic arrays. Dynamic, because you're using dynamic memory management to implement a list like an array, but it's not stuck. So it's not a built-in data type. Arrays are like a built-in data type that you use in the language. The linked list, the programmer in C++ actually creates it. You know, you create the class that you're going to have called the linked list class, and inside you're going to create the item representation, item number, and you're probably going to call them nodes, list items. There's different words for it. It's not consistent. You can actually do that in Java. You can do the same thing you do in C++, you can do in Java. You can create all of that stuff manually by hand. We're not doing that. And only crazy people would do that. Instead, you can use the utility packages that are built into the language, which C++ never had, and say, well, we want to create a collection. Our collection is going to be a set, or our collection is going to be a list. So we inherit extend from this, extend from that. And then we can do list.sort. You know, we don't have to write a sort method to sort our list. We already have it. So the exercise that we're going through in terms of this assignment, the objective of this is actually to get familiar with actually how to use Java built-in utilities in Java classes. Because here's what happens. You take a course like this, you learn the basics. You learn how to use the utilities, how to use the language, how to create an object, inheritance, and all that stuff I'm kind of telling you about. And then you end up like looking in the real world and you have a project and it's a database that's implemented in Java. The database is going to use a collection. It's going to be inherited from a built-in collection class. It's going to work with that. And you actually kind of, like from there, you learn all of the other packages. No one sits there and kind of goes through every single utility and package of the language. It would be ridiculous and way too time-consuming. So you constantly run into new stuff you haven't seen before. This one is common, actually. This is very common. Other things, like in terms of the RMI engine, some of the other component, Java beans and stuff, it's all the same. It's all Java. Just using a different object hierarchy. You're using a different component and you're extending behavior, creating a new object that is a bean, or the new object is a container, or the new object is something of a different type. So this is really the kind of the first exposure to looking at object types in terms of the built-in functionality, which I know, long story short to answer your question, 3 different object types. So, I know it was a long answer, but I think it was actually kind of needed. Because I think some other people are sitting here going, well, what is a collection versus a map versus an iterator? So think of them as different object types, long story short. All right. Now let's go to the root interface. Oh my God. All right, now don't, this is all written for you. Don't freak out when you see this. Because you're going to see a lot of source code examples in this slide set. And maybe this is a good way to present it to you is in little bits. So we're not going to get through all of this stuff today, but I want to just get the concept down. So we have methods for working with individual collections, and the way this slide set's going to work so it doesn't confuse you is we're going to talk about collections, then we're going to talk about maps, and then we're going to talk about iterators. So forget everything. Let's just focus on collections right now. Take a look. For a collection, why, and this goes back to the reinvention of the wheel again, why as a programmer do we want to create all this functionality when we know we want to create a collection? So we extend, we go in there, we import the Java util. We use the built-in abstract because we know about abstract classes and we know about interfaces. And we interface to it and we extend the functionality, which is where overwriting and overloading come into process now. So we can actually use those tools that we've seen so far in a practical sense. And so now we're looking at methods for the individual collection. Well, we have, and I don't have to go through all of these. In fact, this is just a subset. Things that would be related to a collection. As an example, the size. How many do we have in this particular collection or group? Don't like the word collection. You're kind of stuck with it. But you can call it a group, a package, a bag, something, component. Is it empty? Is it full? These are common things that one would actually kind of have to write a method for. How do we add something in? Depends on whether the collection allows duplicates. Is it going to be our implementation? So let's say we want to enforce rules, constraints, where we don't want to add a student into a class if the student already exists in a class. You know, otherwise you get charged with double tuition or something. I don't know, your name shows up twice, you get 2 of everything. We only want 1 in our collection of class attendance or something. So we could build that functionality in when we create our registration class. That's different from another one that we would inherit off of collection that would be doing something else. So which is why the concept of the abstract class comes into place. It tells you what you're going to need to implement, and you decide whether you're going to override it or whether you're going to overload it or whether you're going to implement it, essentially, whether or not it actually even applies towards what you're doing. So we have remove an item, put an item in, is it equal, give me the hash code for it, and then we have the iterator. You know, this is iterator. It's a new iterator class type. It's an object type called the iterator. because every collection has to have a way of finding the items inside of it. You know, we have to have, and then the iterator is giving us our order. So maybe the collection items have IDs that are associated with them. Maybe they don't. Maybe, you know, we can implement this whole iteration concept in a lot of different ways. In fact, in the second assignment, you do it manually. You'll probably have to create a loop to see how many students are assigned to one teacher, or list out when you go to do the toString and you go to print out the information that's associated with each one of the teachers, you're going to have to put a loop in there. Is what you're going to have to do, because arrays use loops, use some sort of iteration manually. Here we can actually kind of implement an iterator and use the built-in kind of to say, you know, give me all in this order, give me that order, sort it alphabetically, sort it descending, ascending, you know, do something to it that's unique towards the functionality. And then we have a toArray, returns a new array containing the references to all of the elements of the collection as an example. You know, create a new object from the object if we have implemented an array object as an example. Return the destination, you know, I don't know, I'm not going to go through all of it, but anyway. So here's more, where we have our primary method operating in bulk from another collection. So looking at one collection and comparing it to another collection. We had seen this if you've worked with the string class. The string object works the same way. What is a string object? If you think about it, it actually comes from collection. A string object is a collection of characters that are ordered. So we have string, first name, Barbara. I got B-A-R-B-A. I got duplicates in there, so I allow duplicates. I've got an order to it, so it's an ordered list. And what is it? It's a collection of characters that I've got in there. So I have to run on that object for the string. I have to write, you know, dot compare, you know. So first name dot is greater than or equal, is less than, is equal to, compare, is it in here? So we have a bunch of methods that we can run on the string object that do all sorts of different things to it. I mean, you can compare it with another one to see if one's inside of another, to truncate the string, to cut the string in half, to do all sorts of different things to it as a collection of character objects. Same concept here. We can build our own methods, and this is the nasty part that you're, I shouldn't say nasty, but this is what you're doing with the assignment, essentially. You're building your own method to add, to remove, to sort, to search. And you're thinking abstractly, how are we going to build from a programming language implementation? We're creating a concept, essentially, to implement it. And, you know, we might have, you know, does this collection contain all of the items that that collection does? You know, we can add one collection to another. We can remove all of the items from the collection. You know, clear it. So the SDK does not provide any direct implementations of the collection interface. So we have a collection interface. We provide the implementation for it. You don't actually have to use it, though. In fact, this was very new. It came out in the last several releases of the SDK. It never actually existed in the earlier stuff. But it was one thing, you know, someone thought about it and said, well, what if we want to implement a collection? Maybe we should have an interface in there. So the interface is setting a template, setting a mold. I shouldn't say the word template, because C++ people don't like that. And I know we're getting short on time. I'm going to end soon. I think I'll end after this slide, actually. I see some information overload already, and I'm only on slide number 4. So, most of the actual collection types are implemented in the interface, usually implementing or extending interfaces such as list or set. So those are kind of extensions off of that. Interface is typically used to pass collections around and manipulate them where the maximum generality is desired. So it's a general interface that's created for the collection. Nothing really spectacular. You would create your own list from that, your own set from collection in terms of the interface. So, oh yeah, this is a good stopping point. I'm going to stop at collection, actually. So you have to remind me, we'll start with iterators next time around. So if this is completely blowing you away, go online, take a look at the Java util. This is the package you want to look at, is the java.util package. Look up collection, map, and iterators, and or get the Deedle book It's borderlines on data structures, but it really isn't. It's just kind of the overall concept. In fact, this is all the data structures you have to know for this class. So next time we will continue with this lecture. And I'm going to have some source code examples for you as well. And I'll pick up the pace a little bit. We'll go a little faster through it. Not too much faster through it, but just to get the initial concept out, I think was important to go kind of slow through it. So, any questions? No questions? What's wrong? Slide, you have a question on slide 3? Okay, what's your question? From the interface class. Yeah. Oh, this is an object though. This is different. This is coming from a different collection. It's not from. Yeah, we're using an iterator inside of the collection to organize the collection. Oh yeah, no, we got objects inside objects. Because inside of the collection object, this is a very good question. Inside the collection object, we have an iterator object that's controlling how we're going through each one of the objects. Iter is from iteration, looping, another word for looping, for going through each one of the items. We have to have an iterator. Otherwise, the collection is useless, right? I mean, we could take the collection, put it inside of an iterator that's outside of it, and not build it inside. We don't have to do it this way. We could implement it any way we want, but the concept of iteration has to be implemented in order for the collection to be navigate it. Navigable is like, I don't know if that's a word, but that's what I was going to say. Good question. Good question. All right. Any other questions before we conclude for today?
CSLO last question. I just need to write the program concept. So we need to write an algorithm for that.
The last question. Oh, this is kind of a late question.
CSLO.
But the last question of the CSLO. Didn't I ask if we had questions about the CSLO essays when I was talking about that? All right, let's see what we got here.
Yeah.
I had a question on the last question of the CSLO essay. The last question of the last question of the last. We have to demonstrate how to solve a problem application. Solve a given application problem.
You need to write in a solid program design for the.
No, as I mentioned before, this is a essay assignment. Don't give me source code for that. You're doing it in words. Everything that you're answering on this particular one, if you select number 5, you're giving me words, not giving me source code. I'm sorry?
Can I write the algorithm and I can explain the algorithm how it works? It is okay?
I don't want you to explain an algorithm either. You are giving me, you're demonstrating how to solve a problem, how to solve a given application problem in terms of the application design with object modeling. Object-oriented design in
like
Java.
Using use cases, actors,
yeah.
I can write it, no problem?
No, you want to solve the problem in terms of what class hierarchy you would create, what would interface with what works with what.
Do you want me to write the class diagram?
Oh, I'm going to take this question offline, but we're officially over with, so you may leave. You may leave, but stick around here for a second. Let me explain this to you.
Can I stop there?
Yeah, go ahead.